welcome back again. We continue the morning session on the Lab Innovation stage with the presentation given by Nektaria Servi of Surface Measurement Systems company, and she's going to talk about materials characterization with sorption techniques. Welcome.
Thank you. Thank you very much, and thank you for being here, and thank you for Achema for giving me the chance to talk about advanced techniques for materials characterization. A few information about Surface Measurement Systems. So Surface Measurement Systems is a British company. We're based in the UK, in London, in Alperton, and our founder is Professor Daryl Williams, who is still a professor at the Chemical Engineering Department of Imperial College. So the company was founded in the 90s, and what we do, we are manufacturing sorption systems for the characterization of solid materials. And when I'm saying characterization, physico-chemical characterization of those materials. The first system that we manufacture was installed at Pfizer in 1992. And our core business as well is pharma industry, and the system still exists. So we're planning to have a museum, I would say, because our systems are quite robust with all our old systems that they exist around the world. So Surface Measurement Systems Holding, as I said, our headquarters are in the UK. We do have facilities in the USA, Allentown, Pennsylvania. We recently just inaugurated a company in India, and our laboratory for contract work in Hyderabad. We do have Surface Measurement Systems GmbH, and also in Shanghai in China. With the rest of the world, we do have various distributors. As I mentioned, our core business is pharmaceuticals. But as you can see on that slide, we're working with various other markets, which is fragrance, clothing, energy storage, cement, packaging, personal care, building materials, and also food. These are some of our customers around the world, and many more is just an example. And these are the DVS systems, our dynamic vapor sorption systems, and also our vapor pressure analyzer. So we do have from water vapor only systems different temperatures from 5 to 85 centigrades with preheaters, with camera. You can hyphenate your systems with different Raman spectrometer, near infrared or IR spectrometer, organic solvents, gases. And also you do have the capability to analyze more than one sample, 2 samples or 5 samples in parallel under the same conditions as well. And also the vapor pressure analyzer, which is based on Knudsen cell. For those that you don't know about the gravimetric technique, so the system, the DVS has got an ultra balance, which is quite sensitive, 0.1 microgram. And then you place the sample of interest on one side, as I mentioned, solid state. And then on the other side stays empty, which is the reference side. And as you can see, you can look at the sorption kinetic of different materials. And also the isotherm plots. So you can use water vapors or organic solvents. So you can look at the moisture uptake. You can look at the moisture transport kinetics. You can see how stable your material is. You can do diffusion, permeability, activation, energy, hydration, and solvate formation as well. by using organic vapors, you can determine the BET surface area, and you can use octane instead of nitrogen or krypton. And it is a non-destructive technique. Surface energy, pore size distribution, heat absorption, and also phase transitions, for example, polymorphs, amorphous stoichiometry as well. This is a typical experiment for sorption and desorption at 25 centigrades, drying process at 0, and also we can see here that it is reversible. Moisture sorption kinetics. And this is an isotherm plot as well, and with the hysteresis you can have some more information about your material as well. And of course, here we can say that our experiment is reversible as well, back to 0. On this slide, you can see the phase transitions, surface adsorption, glass transition, bulk absorption, surface absorption, and recrystallization at different relative humidities. And as I mentioned before, you can hyphenate a camera where you can see how your material is changing morphologically at different relative humidities as well. DVS applications. So as I mentioned, our core business is the pharmaceutical industry. So you can look at the different pre-formulations and formulations as well, excipients, active ingredients, from amorphous content to moisture-induced morphology changes, powder caking, segregation, tablet moisture, barrier blister packs, desiccants as well. And also with the personal care, with the hair, the skin, the super absorbent materials like diapers and pads, we do have really interesting applications, and absorbent materials like zeolites and carbons, and also cosmetics. And then for the food industry as well, packaging, moisture adsorption, moisture-induced phase transition, rapid isotherms of ingredients as well. Packaging materials from pills, capsules, and blister packs, electronic components, packaging of foodstuff, and you can do a calculation of diffusion coefficients and permeability as well. Fuel cell membranes from water uptake and diffusion, electronics adhesives as well, tobacco, building materials, galleries and museums, storage and stability of historical artifacts, and conservation of historic objects as well. And these are our systems which are used to characterize CCUS, carbon capture. The DVS vacuum, which is a gravimetric sorption analyzer where you can use as a probe water, organics, and gases as well. So you can look at fundamental properties, uptakes, enthalpy of sorption, surface area, and vacuum activation as well. The DVS carbon and DVS carbon 5 balances as well, where you can analyze different sorbents like metallic organic frameworks, zeolites, silica, using CO2 and water, and also you can do co-adsorption. CO2 in the presence of water, on water in the presence of CO2. And you can do independent humidity control, cycling temperatures, swing programs as well. And then we do have our breakthrough analyzer Frontier and our MPA for membranes, where you can use CO2, water, organic solvents, and gases as well.